Okay, I want to talk today about doing stoichiometry problems, and these problems that we're going to be looking at are a little bit different than the ones we've looked at in the past for one particular reason. And this is actually something that people have trouble with and get confused by sometimes. The map that we follow, the flowchart or the path we usually follow, we start with a known substance. A lot of times we'll start with grams of a known substance. We convert to moles of the known substance, moles of the unknown substance, and then we go to grams of the unknown substance. Sometimes, though, people get confused when they don't have to go from all the way down one end of the flowchart all the way down to the other. And I want to look at a couple of cases where we're not starting at one end and moving all the way to the other. And the first question that I want to look at is this one. I want to look at how many oxygen atoms are in 10.0 grams of AgNO3. In this case, we're starting with grams of a substance. We're always going to move to moles of that substance. But instead of going to moles of some other substance, we're going to go to molecules of that substance, and then we'll find atoms. So how do we do this? Well, we're starting with our 10.0 grams of silver nitrate, and using the molar mass, we are going to convert that from grams to moles, and then we want to go to molecules. And the conversion factor between molecules and moles is Avogadro's number. So we know that from 1 mole there are 6.02 times 10 to the 23rd molecules. So that'll get us the number of molecules. Now we look at the formula of AgNO3 because we want to know how many oxygen atoms there are in this many molecules. Well, the formula tells us that one molecule contains 3 oxygen atoms, and that's the conversion factor we're going to use. We know that every single AgNO3 molecule, and I really should have written AgNO3 molecules here so that the molecules cancel out, contains 3 atoms. When we do the math here, we find that we have in 10.0 grams of AgNO3 1.06 times 10 to the 23rd oxygen atoms. So we went from grams to moles to molecules to atoms. The next problem that I want to look at, we're going to go from moles. So we're going to start, actually let me put up the equation that we're going to look at first, or the reaction. We're going to be looking at this reaction. I don't need this anymore. Let me move it out of the way. We're going to be looking at this reaction, and I lost my plus signs again. I hate it when it does that. We're going to be looking at this reaction, and we're going to want to know this many moles of K2SO3 equals how many grams of KNO3. So in this case, we're going from moles of a known to grams of an unknown. And a lot of times when people do this problem, for some reason they'll say, I've got moles, I've got to convert back to grams. And they go backwards on their flowchart, away from the direction they want to go. We're not starting at the end, so we're not going to go backwards to the end. We're going to start with moles of known, go to moles of unknown, and then convert that to grams of unknown. So looking at this, the chemical equation tells us that for 1 mole of K2SO3, we've got 2 moles of KNO3. And then using the molar mass of KNO3, we can convert from moles to grams. And we get 40.4 grams of KNO3. But if you're not starting at one end of the flowchart, in this case we started here with moles of known instead of grams of known, you don't have to go back to the other end. Go from where you start to where you need to go, and make sure you have your path mapped out clearly before you start.